I am particularly pleased to be able to introduce our next speaker, our luncheon speaker, who I heard at an invitation-only insurance meeting annually held in New York City, sponsored by St. John's University and their very renowned insurance program. And when I heard Dr. Waller, I said, wow, he is so relevant to us in Louisiana, and for that matter, all coastal states in particular. I would love to have him come to our conference, and I am so glad he was able to make it work with his schedule. Dr. James Waller is a research meteorologist with Guy Carpenter Global Strategic Advisory, responsible for extreme weather advisory and post-event analysis and testing and evaluation of catastrophe models. He also represents Guy Carpenter on the Insurance Institute for Business and Home Safety Research Advisory Council. Prior to joining Guy Carpenter in 2012, Dr. Waller worked with a team to define tornado-prone regions for the National Building Code of Canada, and also reviewed Canadian snow and wind loads under present and projected climate conditions. Dr. Waller's practical experience includes instrument testing and evaluation, weather observation networks, and deployment of a marine observation station. He earned his BA in Science in Engineering from the University of Waterloo in Canada and graduate degrees in meteorology from Florida State University, where he was also an instructor. And I recall some point in time hearing a discussion, watching the Weather Channel, of Tornado Alley through the Oklahoma-Kansas area. I guess something had gone through there and done a lot of damage and devastation. Actually, the year I was president of the NAIC, the Moore, Oklahoma killer hurricane, with the children in the grammar school being losing their lives as a result, and me being asked to go and tour in a helicopter the devastating effects that had. But the Weather Channel story another time said that as bad as Tornado Alley is, and I'll ask Dr. Waller to confirm this as correct or not, what's known as Dixie Alley is more of a killer, hurricane killer area than Tornado Alley. And we saw what just happened to our friends in Nashville night before last, and the reason for the difference is the population density in that Dixie Alley area versus the more sparsely populated Tornado Alley in the Midwest. If that's correct, I'd appreciate confirmation. It is. Thank you, Doctor. We look forward to your remarks.
Commissioner, thank you very much. And ladies and gentlemen, it's a pleasure to speak with you today and very much appreciate the invitation. My role here today is to talk about issues around climate change from a position of relevance to the Commissioner's earlier statements, and to focus on documents from the Intergovernmental Panel on Climate Change and from the United States National Climate Assessment. Let me talk about those two documents very quickly because they form the basis of this presentation today. They're the product of some very, very careful vetting by experts in the field to develop scientific consensus from the available scientific literature and to focus on that literature which is most carefully constructed and to steer away from those who are more interested in sensationalism rather than actual science. It's a good body of literature. They both produce an executive summary or a summary for policymakers, which is written in accessible terminology, provides a really, really good basis for the issues, whether it's real or not, and more importantly, a sense of directionality for the trends with respect to extreme events, which are very, very relevant to our industry, especially from a property cat perspective, but also from a life and health insurance perspective. There's some things to think about over the longer term. So I encourage you to review those documents, the summary for policymakers of the Intergovernmental Panel on Climate Change and the United States National Climate Assessment, and come to your own conclusion, come to your own view after reading those documents. And if anybody asks, they're publicly available and they're well constructed. So my role here today is to talk about the issues. I'm going to talk about whether we believe it's real or not, what the contributors are to climate change. and also to talk about expected trends that we have seen and observed and which are unequivocal, and those trends that we might expect under different climate change scenarios. And I'll close with a broader industry perspective, but the main focus here will be from a property cat perspective. So to lead off, let's look at a picture that is really, really hard to see from the back of the room, but I'm going to show it anyway. It's a picture of the radiation balance of the Earth. The yellow shades indicate energy that comes in from the sun with shorter wavelengths. It hits the Earth heats as a result. The Earth has a temperature, so it emits radiation back out into space. Some of that radiation is trapped either by clouds or by water vapor or by greenhouse gases like carbon dioxide, methane, or others, water vapor in particular. And after absorbing some of that radiation that we see in the oranges, some of it is sent back to Earth. And the Earth absorbs that radiation as well. It's a process very similar to what you see inside of your car on a hot day. Energy comes in from the sun, heats the interior, especially if it's a black leather interior, emits some of it back out. The windshield traps it, emits it back into the interior heats up. So given the chemical composition of the atmosphere, the Earth radiation balance is really, really stabilized at equilibrium to a temperature on average of about 60 degrees Fahrenheit. That's the average global temperature of the Earth, or 16 degrees Celsius. That happens to be the perfect temperature range to support human life. Well, isn't that a coincidence? In the meantime, we've seen a drastic increase in the amount of carbon dioxide in the atmosphere. That's the bit that I've shaded in red on the right-hand side. So that is altering the radiation balance to pressure the Earth towards a higher temperature over time. This is a picture of carbon dioxide concentrations over the last 800,000 years. Did we have carbon dioxide sensors 800,000 years ago? No. But we can dig an ice core sample in the Antarctic, look at the carbon concentration at the bottom of that core, and infer what the carbon concentration would have been at that time. So what do we see here? Well, we see a lot of variability from millennia to millennium over hundreds and hundreds of thousands of years. Some peaks, some valleys. Some of these are consistent with past temperature trends that we believe occurred over the last 800,000 years or so, all a result of natural variability. What we see at the end of this picture, though, is a spike in the purples, and then the green and reds are what we have actually measured through carbon dioxide sensors over the last 100 years or so, and we see a spike. And there's two things. The rate of increase is the highest that we believe ever occurred. And this peak here is higher than any of the peaks that we believe occurred over the last 800,000 years. So again, that alters the radiation balance of the Earth to exert a pressure towards a warmer temperature. Does that mean that the Earth is going to end tomorrow? No. But it does exert pressure on weather patterns and some changes that we will need to adapt to over the coming decades. So this is forcing a tendency towards a warmer climate. So we're going to look at a different picture here, which is temperature relative to the 1960 to 2010 baseline. The black line indicates where we were with respect to that mean, and there's a lot of variability from year to year, from decade to decade. Some cool periods, some warm periods. Yes, natural variability very much exists through a number of contributing factors, including the radiation balance. Sometimes volcanoes go off and it cools things down. Sometimes leftover carbon dioxide from a natural process will exert pressure towards warming. These green shades are kind of hard to see from the back of the room, but there's a lot of variability from decade to decade. This is a sense of the standard deviation around the mean. It's a sense of how variable things are from year to year. When we look at the period of the last 110 years or so, where we actually had temperature observing records, we notice a big spike in the global mean temperature of the Earth. Two things I want to point out. The rate of warming is the steepest that we believe has occurred in known history, acknowledging that there's a lot that we don't know about this world of ours that we live on. The other thing is that this spike here is higher than any of these green shaded regions that we've seen over the last couple of millennia. So that is a statistically significant increase. And if we think back to our nightmares from statistics class, that statistically significant increase indicates that it cannot be explained away as just random variability. And there's a gentleman named Francis Weirs who actually invoked a statistical process, went through the math, went through the deep statistics of it, and two conclusions came out. One, the rate of increase that we've seen in the global mean temperature of the Earth is not something that you could explain away as statistical noise, and made that statement. The other piece is that natural variability is one contributor, but it doesn't explain all of the increase. So there is something else going on there. So those two bits are a compelling argument. In the meantime, ocean water is heating at depth. If anybody has heated a pot of oil, maybe in a deep fryer or something like that, versus the equivalent amount of water, it takes a lot longer to heat the water, right? Everybody nod your heads? Okay. It doesn't take long to heat oil. It takes a lot longer to heat water. It takes a lot of energy to increase ocean water and the temperature of ocean water by the rates that we have seen over the last 100 years or so. In the meantime, our ice caps are retreating. We've seen glacial retreat across the world. And in the meantime, when we look at proxy records from ice core samples and the distance between tree rings, which actually increases during a warmer year, it creates a pretty compelling body of evidence that something is going on. Again, something for which we acknowledge natural variability, but it doesn't explain all of what we've seen in recent decades. There's one more piece that I want to show you, and it's, again, a bit tricky to see from the back of the room, but this picture that we're looking at here is similar to the one we were just looking at, except it's from the late 1800s through present day. The black line means the exact same thing. It's the mean temperature of the Earth relative to the 1960 to 2010 average. There's a lot of variability from year to year. The blue shaded region shows output of climate models. Now, climate models are different from numerical weather prediction models that we use to tell us where the hurricane is going to go. Global climate models are meant to be forward-looking on a decadal basis, and they're meant to run at a coarse scale for the Earth at large, and also to account for temperature, barometric pressure, and some averages of precipitation and other meteorological fields. They don't give you the same detail as a numerical weather prediction model. Weather prediction models for day-to-day, and getting day-to-day and even hour-to-hour right, but the global climate models are meant to get decades right. So that's the blue shading from global climate models. So year on year, do they get every single year right? No. But they get the trends right. They get the slow curve right from the 1920s through about 1960, and they get the acceleration in temperature right from about 1960 onwards. Okay, so that's interesting. These are the same models that we're using for forward-looking projections. So there's another piece to this. With a global climate model, you can actually restrict carbon dioxide levels in the model, in the software, such that they are fixed at those carbon levels of the late 1800s. And when you run the same model, but with carbon levels restricted to the late 1800s, you get this green shaded region. They're too cold. The model's telling us that the Earth temperature should be colder on average as compared to reality if you restrict carbon to late 1800s level, and I find that a compelling piece of evidence as well. So do we know unequivocally that increased carbon is causing global warming? No, we don't know that. There's a body of statistical evidence that tells us that it cannot be ruled out as a contribution of natural factors alone. There's something else going on. By the same token, we also don't know unequivocally one-to-one that smoking causes lung cancer. We have a body of repeated statistical trials that point in that direction, and it's now accepted as common sense. So that's the scientific background. I could go into detail on this for another hour, but we're restricted for time. So let's talk about trends instead, because these are very relevant to the property cat space. We had another speaker in the other room talking about flood insurance, a gentleman from Swiss Re. And one of the more pressing trends from a property cat perspective is sea level rise. And sea levels have risen on a worldwide basis and at different rates, partly because the continents are doing different things in different parts of the world. On the East Coast, the continent is actually sinking a little bit. But in the meantime, Hudson's Bay is actually rising. So the sea level trends are a bit different. Here in the northern Gulf region, the continent is actually sinking bit by bit, partly because of sediment compaction along the Mississippi Delta, and in part because of energy activities. In the meantime, the bulk of sea level rise can be explained by increasing ocean volume. The oceans are getting warmer. That means that the volume is increasing. That explains the majority of it. The other piece of it is that with glacial retreat and with retreat of the ice caps, you're letting a lot of fresh water escape into the oceans. And that also is contributing to the increase in sea level that we've seen on a global basis. And again, there's variability from point to point. Now, when we look at Grand Isle, Louisiana, with the tidal gauge there, we've seen an increase on the order of 2 feet over the last 70 years at Grand Isle, Louisiana. That's what we've seen. That's unequivocal. And if you go to tidesandcurrents.gov, you can pull this plot into a deeper analysis if you're interested. The global climate models are giving us a projected increase in this region on the order of 4 to 6 feet by the year 2100 for the northern Gulf region. I will not care by the year 2100. However, I think the property cat industry will. Why? Because with an increase in sea level, it compacts the return periods of any coastal flood event, from hurricane, from winter storm, from whatever. And it actually expands the footprint of those areas that would be inundated by seawater under a storm surge event. And again, those return periods will be compacting. So that's what the best projections are telling us. That's our best sense, according to scientific consensus. Ice sheet instability might increase these numbers. There's some point of uncertainty there. It's a significant threat from a property cat perspective and also from an infrastructure perspective. Any low-lying area that's adjacent to the coast is projected to come under increasing threat over the coming decades. Will this affect our policies and contracts year to year? No, we adapt differentially, but from a strategic standpoint, the men and women in this room thinking forward might have some issues to think about. So here's a picture of those areas prone to inundation now. Just normal day-to-day Gulf of Mexico doing what it does. If we do a 2-foot increase above the current mean high water, these are the areas that turn blue. The areas that turn blue are going to be more prone to seawater inundation on a more frequent basis. And for 4 feet, it moves just a little bit further inland. The Atchafalaya Basin and the Mississippi River and immediate coastal areas come under increasing threat. It's especially true for areas south and west. And that's what the picture looks like at about 6 feet above mean high water. I acknowledge that it might be hard to see from the back of the room. Our aim is to make these slides available via PDF, and I'll rely on the department to circulate these after for those that are interested. And again, these are available on tidesandcurrents.noaa.gov if you're interested in digging further. And there's a good website there that lets you look at these pictures and also do some deep digs on a point-to-point basis to look at scenarios. And it's useful from emergency response planning as well. So that's sea level rise. And that's a big threat from a property cat perspective and from an infrastructure perspective. You think about gas lines, sewage lines, drinking water lines just getting regularly inundated, maybe bridges. There's some things that we need to think about from a forward-looking perspective. That's an hour-long discussion just on its own. So let's think about hurricane frequency and severity, just the storms themselves. I've heard it said in some sectors that because of global warming, hurricane frequency will double. Okay, that makes me scratch my head a little bit. And I have no hair left, but that's another story. So let's look back over the last 110 years or so, 118 years specifically, at a measure called accumulated cyclone energy. What that means in English is you take the 6-hourly position reports from the Hurricane Center for maximum sustained wind, looking back historically for every single storm. You take that number, you square it, you add it up over the year. That gives you an annual measure that's a rough proxy for the amount of energy expended by a hurricane or by all of the hurricanes over the course of a hurricane season. I've also heard it said recently that we've seen an escalating trend in hurricanes, especially with 2017, and it's exactly due to global warming. Well, careful, we don't know that. Let's stick to what we know for a second. Looking at this metric, if you do a 5-year trend ending in 2017, it looks like the world is coming to an end. Fully acknowledge that. But when you look at the same time frame and look at 04 and 05, you can make the same argument. We acknowledge along the way that we're better at catching hurricanes that occur in the basin through overflights that started after the war, and then satellite detection, which really came into its own in the late 60s. We're just better at catching hurricanes in the basin. So we might see an upward trend because of better detection. If you step back and look at this picture and look at the long-term view, there's no evidence of any long-term trend in hurricane activity from the 1900s through present day, even after accounting for better detection. 2017 was an incredibly active year in its own right, certainly among the top 10 in recorded or known history. There may have been more active seasons in the 1600s, but we didn't have satellites then, right? But if we look further back, look at 1926, the year that produced the Great Miami Hurricane. The energetics of that year were on par with 2017. 1933 was another incredibly active year. Betsy in 1965 actually was a quiet year. There's 95, there's 04 and 05. We've seen seasons of this activity before. We will likely see them again. We entered an active period beginning about 1995, and there's scientific debate about whether it's related to natural oscillations in the Atlantic or whether it's due to global warming. And it's hard to disentangle the two. We had aerosols in play in the 1970s that were blocking some sunlight. It might have cooled the oceans off a little bit. It might have cooled off hurricane activity during that time. We don't know. But definitely something to keep an eye on. So that's what we've observed. Nothing to date that we can extract from the annual variability and the noise involved. What about projecting forward? Nothing observed to date. Looking forward, it's intuitive to think that because the Atlantic and the Gulf of Mexico are warming that we will see more hurricanes, but the Pacific is warming at the same time. When it's warm in the Pacific, it makes it windy at flight level over the Atlantic, and that tends to suppress hurricane activity due to a process called wind shear. So which one wins? We don't know. I've also seen different modeling studies looking at hurricane frequency over the long term through the 2100s give just different directions depending on the physics involved. So there's still a body of active research involved on frequency. So the best answer is we don't know. Let's be dead clear on that. But the other piece is that with a warming Atlantic and Gulf of Mexico, you're increasing the speed limit of hurricanes and how strong they can get. That makes sense. Hurricanes like warm water. They feed off of that energy through a process that is another hour-long discussion. So the best estimate, according to the scientific consensus, is that we can expect some increase in intensity over the longer term, probably on the order of 20 miles per hour. That's our best guess right now. So that takes Ike, which was a high-end Cat 2, and puts it at a low-end Cat 3. And damage on a structure increases according to the square of the wind speed. So things will break to a slightly greater degree of severity. Okay, so that's something to keep an eye on from a property cat perspective. Will it affect next year's policy? Probably not. But thinking forward from a strategic perspective, this is a relevant question for the industry at large and from the men and women of the companies in this room. So the frequency might not change. We really don't know. But we should see a higher proportion of severe hurricanes as a result of warming temperatures alone. And this is consistent with the theory of how a hurricane generates wind relative to ocean temperature. So the machinery and the science works for this argument. Along the way, we will probably see an increase in hurricane rainfall intensity. As air warms, it can hold more water vapor. The machinery of a hurricane will do its thing and likely produce higher rainfall amounts over the longer term, and this has implications in terms of rainfall intensity and inland flooding. There's some evidence that they might be slowing down. The jury is not completely set on that one yet, but it's something to keep an eye on, especially when you think about Harvey and what it did with producing rainfall rates of 1 inch per hour, sometimes 2 inches per hour, and moving at a mean forward speed of 2 miles per hour and lingering for 5 days. The math on that rainfall really was not pretty, as some of the men and women in this room are fully aware. So that's something else to keep an eye on. Let's switch from hurricane to severe convective and think about tornadoes. I get a question a lot about whether a warming climate will mean more tornadoes. And the answer is we don't know. Tornadoes depend on a very balanced environment with very unstable air, lots of moisture, and winds doing just the right thing as you go up from the surface. And it's hard to tell which one will win out over the longer term. What we've observed to date is that tornadoes, the days that produce tornadoes appear to be on the decline on a US-wide basis. But on those days that produce tornadoes, we're seeing more of them. And that is evidence of some clustering. There's a slow upward drift in those days that produce 30 or more tornadoes over time. So it's not a doubling that we've seen in the last 5 years, but there's a slow upward drift that we've seen over 30 to 40 years. That tells us that the tails are thickening, even if there's no real change to the mean. And that, again, is something to be aware of from a property cat perspective and thinking forward in strategic terms. In the meantime, your traditional tornado alley that you see here appears to be cooling off in terms of tornado activity. The picture on the left shows days in which a tornado was observed. And the picture on the right shows days in which an environment was in place to produce tornadoes. Those perfect conditions that I mentioned of moisture, instability, and winds doing just the right thing with height to produce rotation. So when you look at the environments with this picture on the right-hand side, the I-35 corridor appears to be cooling down. The blue shades show a decline over time from 1979 to 2017. The black hatch marks show a statistically significant decline, and we've seen the inverse of that for points along and east of the Mississippi Valley, which includes the state of Louisiana. So those days that could produce tornadoes appear to be on an uptick in Louisiana. So that's a point of interest. For hail, this is a picture showing relative increase in days that could produce hail. Same sort of idea as the right-hand picture and the tornado picture that I just showed you. Most of Louisiana is red, but the statistically significant regions are really in the northwest corner. And when you get closer to the coast, there doesn't seem to be that much of a change in days that could produce hail. And part of the reason for that is as you get closer to the coast, the freezing line is further up off the ground. Hail has more time to melt before it reaches the ground, so we don't see severe hail quite that often. And frankly, the air is just too warm. But as you head north and west, there might be something going on there. We've also seen a trend, an observed trend, with a possible slow upward drift in 2-inch or higher hail across the U.S. at large. And this might be consistent with the claims experience of some of the people in the room. Has it doubled in the last 10 years? No. There's a slow upward drift, something to be conscious of, and again, indication that the tails might be thickening. And this, again, is something to be aware of from a property cat perspective. So this next slide says pretty much what I said for observed tornado days. They appear to be becoming more productive. There's that spatial shift that I mentioned. If tornado activity heats up along and east of the Mississippi River basin, more people live there, there's more to be broken. And that's producing escalating losses just from a population concentration perspective alone, irrespective of any change in the hazard. It's projected that hail environments will increase over time, not so much so for tornado. The guidance is really unclear on what tornado trends are going to be doing over the longer term. We're just aware of what we've observed. And that's the best estimate according to the scientific literature. When we think about hail, I mentioned that possible upward drift. We've seen a spatial shift. Hail days appear to be occurring more frequently, and it's likely to continue through the year 2100, just because thunderstorms will have more juice to work with due to warmer air. The number of days that could enable severe weather will likely increase, but with a lot of seasonality. So the early spring and mid-spring months will likely become more aggressive according to current guidance, but deep summer will likely slow down, just because it'll be so much warmer and the air will actually be a bit more stable. And the variability is likely to increase as well. For thunderstorm wind, the guidance is unclear. It's believed that more instability will produce more aggressive thunderstorms. Wow, that's quite the ring. Hopefully that doesn't keep up. Our trusty sound guy is going to help with this. I can talk to the back of the room, but I don't want to deafen the people at the front, so. For wind, it's tricky. More unstable air would likely produce thunderstorms with more juice, but especially during the deep summer months, it's estimated that wind shear would decrease. So which one wins? We're not sure. You need both to produce severe weather. We'll have to wait and see. One thing that's emerged from the guidance is a longer severe convective season, a lot of seasonal variability, especially in the spring months, and probably a busier spring and a quieter summer. And that's the best that we can tell for severe convective. There's another piece running under the hood, and I mentioned this earlier. We're just building more, and it's costing more, and population concentrations are increasing, especially in urban areas. And that is going to produce an upward trend in losses, regardless of what trends we see in the physical hazard. It's certainly true for hurricane, certainly true for severe convective. What you're looking at here on the bottom row is a picture of the Chicago metro area over time. I think that's Chicago. And we've superimposed the Joplin footprint. And over time, the densely populated urban areas have really increased in coverage, and it's projected to continue through the 2050s and even into the 2100s. This is a way of simplifying the process. If you think of the dark red as being your super urbanized areas, the orange being suburbs, and the yellow being kind of semi-rural, somewhat populated, but not really. As these areas expand over time, if you replay this same tornado under different population scenarios, you're going to see an upward trend in losses just because there's more to be broken. The probability of catching a tornado in a densely populated urban environment will gradually go up with time. That's another important piece of the puzzle. And I wouldn't presume to comment on the portfolio management of the men and women in this room, but it's an important point to be conscious of. Temperature is also important. It's also going up. And what we're looking at here are two scenarios. The red is a high carbon emission scenario where the world does nothing to reduce carbon emissions. And the blue is indicative of aggressive mitigation scenarios where we just shut carbon down. Notice that the temperature keeps going up for a bit because some of this is baked in already. Well, why do we care? Well, a slight increase in the mean doesn't really seem like that big of a deal, but if you think of adding another day to the heat wave events that we see, especially in the Deep South, and maybe having 2 more of them on an annual basis, okay, that's something to think about. That has implications from a business interruption perspective, from a power management perspective, in terms of the power grid and infrastructure and its ability to sustain the load during sustained heat wave events. It also has implications from a health and safety perspective. These are things to think about over the longer term. What we will likely see is an increase in heat wave frequency and severity. That's projected to continue. We've already seen it. We've already observed it. The last decade was the warmest on record. We'll likely see a decrease in cold spells, both frequency and duration, and these trends are projected to continue through the 2100s. The persistence of these periods, warm, cold, rainy, dry, is likely to increase a bit. We've seen periods in the South recently, especially along the I-20 corridor, where it just rains day after day after day. That's projected to continue as well because there won't be as much to kick these weather systems out. On the flip side of that, if it gets dry, it might stay dry for longer periods of time. If it gets hot, it might stay hot for just a bit longer. So that idea of persistent weather patterns is something for which observed guidance is really murky still, but in terms of our projections, that is something that we will really need to think about. It has implications from a flood control perspective for temperature. It has implications from the perspectives that I mentioned before for energy, even for agriculture, because different plants like different temperature regimes. It also has implications for heat-related illness, disease, and wildfire. So something to think about. I mentioned precipitation. Our expected change in mean annual precipitation for the state of Louisiana is probably not going to change all that much through the 2100s. Some of the resilience measures to think about include stormwater management systems and retention strategies, how frequently you clear out the retention ponds and that sort of thing, and also land use strategy. There's a complex network of political and economic constraints in play for these issues, and they are very, very regional in nature and involve some questions around infrastructure. So this is something else to keep an eye on. This loops back to the idea of persistence. What we're looking at here is the Southern U.S. Annual Climate Extremes Index, which includes Texas and Louisiana and some other adjacent states. So the ingredients for these numbers include days where your temperature was in extreme, either hot or cold, days with rainfall in extreme, either heavy rainfall or periods of extreme drought. So these are the ingredients to the numbers that we see here. We've seen a lot of variability from year to year. We saw a spike in the 1950s. We're in the midst of another spike now that has actually surpassed the 5-year running mean of what we saw in the 1950s. So even if the means are not changing all that much, the extremes appear to be becoming more extreme. Again, do we know that it's entirely related to global warming? No. But the statistics tells us that it's a piece of it, at minimum, and something to keep an eye on. So warm trends might last a bit longer. Wet trends might last a bit longer. Dry trends might last a bit longer. These are some things to keep an eye on. Stormy periods might last a day or two longer. An individual hail streak might not cause damage, which is overly remarkable on its own, but if the period lasts another 2 days, it can be quite impressive in the aggregate. And we've noticed that for both single state mutual companies as well as some of the large titans that play in the insurance space. So definitely something to keep an eye on. There are solutions to this, but it's good to be aware of the trends over time. So what can we do about it? Well, we can reduce carbon emissions. That's a 2-hour discussion, and I'm happy to have that with anybody in the room, preferably at the bar. That aside, from a practical perspective, let's think about the different issues that we talked about and what we can do to get ahead of these issues. I'm of the belief that our building stock in this country and infrastructure is not equipped for today's climate. And there's a lot that we can do to bolster our building stock and infrastructure in this country. The FEMA recommendations concerning elevated foundations in those areas prone to coastal flooding, I've witnessed firsthand that stuff makes a difference. Will it stop a Katrina-like storm surge? No, absolutely not. The storm surge of Katrina was 28 feet. And I have personal interest in the Mississippi Gulf Coast that experienced that firsthand. It's a tough go. In the meantime, we'll get this lesser severity but more frequent storm surge activity. When you think about the sea level rise implications, if we elevate our structures that are in those areas that are prone to regular coastal flooding, that will make a difference. There's a restaurant in Biloxi called the Harbor House. It's McElroy's. Some of the people in the room might have been there. It's now on an elevated foundation up to exactly 29 feet above sea level. That's a statement. I love it. And it's great to see that restaurant back. And it's one of the staples of Biloxi. It can prevent this type of damage. This was a home that was resting on a pier and beam foundation on Jersey Shore. Was not on elevated foundations, and it was picked up and just floated inland the distance of about a football field with tragic consequences. If you look carefully at the structure, the roof is in almost pristine condition, which is consistent with the belief that while there were pockets of wind damage that were very impressive in the aggregate, the true severity of Sandy was borne out in the seawater flooding due to the storm surge. Sandy made landfall as an equivalent Category 1 post-tropical cyclone, but the storm surge was just incredible because of the size of the storm. And through elevated foundations, I witnessed firsthand that there was less of this type of impact for those homes that were actually on elevated foundations. Were they spared damage? No, but they do make a difference. So I talked about coastal flood, elevated foundations. Coastal flood defenses might be practical in certain areas. Near-shore wetlands and wetland replenishment can reduce the energy of wave activity during a heavy-hitting coastal storm event. For inland flood, it's a question of stormwater management and retention systems, as I mentioned earlier, and also land use. The political and economic constraints from region to region can be quite tangled, and it's a deeper discussion, more time than what we have for in the session today. What can we do for wind? Well, if you have the roof on right, that's a start. If you have the roof sealed properly, attached properly, and we'll vet it along the edges, the roof might stay on just a bit longer during a tornado. The degree of damage will be much less severe, and the homeowners will actually have a viable living space following the tornado. You can make the same argument for hurricanes. Will these measures stop an EF5 tornado? No, absolutely not. But they will reduce the degree of damage for an EF1 or an EF2. It has the effect of reducing the damage footprint, providing for a more viable space for homeowners at the end of the day. And by the way, it reduces cost to the insurance industry and also to reinsurers. It's a bonus for everybody involved. Does it cost a bit more at the front end of construction? Yes, absolutely. But relative to the cost of the home and the lifetime of the home, it works to the favor of the homeowner to make that investment on the front end over the life cycle of the home. Something as simple as hurricane clips reduces torsional loading, structures less likely to fall apart during the tornado. So putting this into practice, let's think about Charlie from '04. This is a picture of a study done by the Institute for Business and Home Safety, of which Guy Carpenter is a member. We're looking at claims frequency on the left, claims severity on the right, and this is from a post-event survey conducted in Charlotte County after Hurricane Charlie went inland. And you can see that those building codes for post-1995, with attention to some of these resilience measures, clearly make a difference in Charlotte County, both for frequency and especially for severity. As another observation, those homes that were built prior to 1970 were just leveled. They were scraped right down to the foundation with terrible consequences for the homeowners. So these measures have been field tested to make a difference. They were demonstrated again to make a difference with Irma on the Florida coast, and also for portions of the Florida Panhandle when Michael went inland. And if anybody is interested in learning more or providing a body of education for your policy holders, go to the Institute for Business and Home Safety. They do a ton of good work, and there's a lot of really good guidance that's a benefit to homeowners at large, and probably to some of the men and women in this room. So in closure, this is a Cliff Notes version of what I just said about trends. We'll make this available following the session. There are other forms of risk. We've been talking a lot about physical risk from a property cat perspective, but there are other modes as well. Transition risk, the potential that an abrupt transition to a low carbon economy might cause investments to lose value. That's another point of interest for the industry at large. And there's also liability risk, which is the risk of one being sued for one's role in creating climate change. Those are some other broader points that we're following. In the meantime, the regulatory pressure in London is increasing. It has implications for the large global insurance companies. And there is talk domestically about certain regulatory measures or disclosure measures. New York State and the state of California have gone there. And there's talk in other states, and also with NAMIC and others about what to do about the climate change issue. We're not there yet, but it's something that we're following. And in the meantime, investments are being targeted towards those assets that are believed to be more sustainable, irrespective of climate change. So those are a few other things that we're keeping track of beyond the property cat space. But again, from a property cat perspective, these are the key issues: sea level rise, tropical cyclone severity, maybe some things going on with severe thunderstorm. On an annual basis, we'll adapt differentially, but thinking forward strategically, these are some points to be aware of. Ladies and gentlemen, an absolute pleasure to speak with you today. Thank you for your time, for your attention, and thanks again to the Commissioner for the invitation. Thank you. My message here today was about the growing importance of climate change for the insurance and reinsurance industry. It will generate trends with respect to sea level rise. It's a trend that we have observed and is projected to continue over time. Hurricane frequency, we're not so sure, but severity is likely to decrease, although no trends have been observed to date. And there have been some interesting trends concerning severe convective activity. Over the longer term, some things that we can do to get ahead of this are to think about resilience measures for structures, for infrastructure, for property, all of which are very important. And along the way, we'll see increasing attention from a regulatory standpoint that might be of interest to the industry at large. Thanks.
What kind of recommendations do you have for Louisiana?
For the state of Louisiana, think about building stock and infrastructure, structural resilience, and flood control infrastructure. Those are some things that can make a difference. The Institute for Business and Home Safety does some really nice work around structural resilience, and homeowners, policyholders, insurance companies can look to their guidance to think about what we can do now irrespective of climate change trends. And along the way, let's think about sea level rise and the flood issue.